Okay, in this video we're going to go over the vertex formula in quadratic functions. This is really part 4 of a series of videos I'm creating about the quadratics and quadratic functions because it's such a rich area and there's so much to know in it that I'm just going to chunk it up into 4 smaller, maybe even 5 smaller videos. So anyway, what's the vertex formula? Remember that a parabola is a graphed line with a degree of 2 that looks something like, whoops, I should have done it this way, something like this, right? So it is a curved line that can be divided evenly in half with an axis of symmetry that goes right down through the middle of the parabola and creating 2 mirror images on either side, right? Now, what is the vertex? The vertex is the very, very tip of the parabola. So when it's down here, this vertex, right, this very, very tip is what they call the minimum because it's the bottom of the vertex. So let me just write this over here, minimum. And in the same way, when the very, very tip of your parabola is at the top like this vertex is called the maximum. Maximum. Now remember, these parabolas are always on an XY graph, right? And so every point on this parabola, let me just go ahead and draw one. Every point on a parabola actually is a coordinate of some kind, isn't it? So if I were to do something like this, okay, I would know, for example, that the vertex here is some point. It looks like it's a negative x and a negative y, okay? It looks like the y-intercept is some kind of y equals, right? Where x is 0, y is equal to some number. We know what we're coming up is that we're not going to be able to also find out where the x-intercepts are, but that's for a later video. But we do know, again, like the vertex itself and the axis of symmetry has some kind of a point associated with it. And that's what we're going to learn with the vertex formula. Now let me just write what the vertex formula is. The x value is negative b over 2a, which you might recognize as the equation for the axis of symmetry. The y value, though, is the following: 4ac minus b squared all over 4a. Now, what are these a's, b's, and c's that we're talking about? You'll remember in a previous video, we were talking about what the coefficients of a quadratic function are. Coefficients. That's what these letters are. The a, the b, and the c are the numbers in front of the variables in a quadratic function. Here's an example. I know that the standard form is f of x is equal to a x squared plus bx plus c, don't I? And I know that the a is called the quadratic coefficient, the b is called the linear coefficient, the c is called the constant. If I were to give this an actual equation with the a, the b, and the c having numbers, right, I would say f of x would be equal to something like, oh, let's just make one up, 2x squared plus x plus 4. Okay? Identify what the vertex is from this particular quadratic function. Okay? Well, the first thing I would have to do is identify the a, the b, and the c. The a here is 2. The b doesn't look like it has a number, right? But remember, what is the number that's understood to be in front of a variable if there's nothing showing up? We know that it's always 1. And finally, the c, in this case, would be equal to 4. So we're going to be able to figure out where the vertex of this particular function is just by looking at the a, the b, and the c. Okay? Now let's go ahead and just plug them in to the formula that we wrote up here. So we know negative b over 2a would be the same thing as saying a negative 1 over 2 times the a we know is 2. This turns out to be a negative 1 over 4. So I know now that the axis of symmetry, or just the x value of the vertex, is a negative 1/4. The b is this formula up here. Okay, so let's plug our numbers into there. Again, we know that it's 4 times a times c. Oops, let me get that up here in this. All over 4 times, minus b squared, don't forget that. B squared over 4 times a. Let's put our numbers in. 4 times the a we know is 2 times the c we know is 4, 4ac, minus b, which is 1, quantity squared, over 4 times a, which again we know is 2. That's going to give us, let's just go ahead and evaluate this now, right? 4 times 2 is 8. 8 times 4 is 32. Minus 1, because 1 squared is just 1, all over 8. This turns out to be a 31 over 8. So the vertex for the parabola that I've written here is going to be negative 1/4 and then 31 over 8. That tells me that my vertex is going to be a negative and then a positive. So somewhere up here, I know that my parabola is going to open upwards, and I know that the y-intercept will be a positive 4. If I wanted to do a quick sketch of this, it would probably look something like this. Negative 1/4, positive 31 over 8, which is just a little bit shy of 4. So there's that. The y-intercept is 4 because we know that from the c constant. We know that it opens upward, so it's going to look like this. And we know that the axis of symmetry is just the x value, which is negative 1/4. Okay, so there's my quick sketch of this particular function. Okay, I hope that was helpful to you.